Prepare to meet your doom. I mean, no, actually, we're just going to multiply a decimal by a decimal here. Sorry, got a little crazy. Looking at our first problem, though, we're looking at 32 and 5/10 times 1.2, or 1 and 2/10. So, I personally don't like dealing with decimal points when I'm doing multiplication. So here's what I want to do for a second. Let's pretend they don't exist. So what we're going to do is, let's turn this number into 325. Now, how did we do that? We basically moved the decimal over one place. We made it 10 times bigger. And here we moved it over one place as well, so we ended up with 12 instead. Now remember, just like we talked about with the compatible numbers, we started off by here, but we made it bigger. So remember, we're going to eventually have to take that away. We're going to eventually have to make this number 1/10 of its size. And we're eventually going to have to make that number 1/10 of its size. Now we know that 10 times 10 equals 100. We also know that 1/10 times 1/10 equals 1/100th. So what we're eventually going to have to do is, whenever we get our product, we're going to have to make it 100 times smaller, 100th of the value here. So the way we can do this is we can actually rewrite the entire problem as 325 times 12 times 100th, meaning after we get the end product, we just have to make it 100 times smaller. And then we've got the answer here. That's easy. So let's go ahead and actually try and solve the problem now. Alright, so let's grab this guy here, pull him over here, and let's take this other stuff and shrink it off to the side. So let's just go ahead and do some simple math here. So 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6. Alright, I'm done with that. Done with that. Boom. Drop kick. Oh, look at the tears of sadness. That's right. Anyway, moving on. So now we take 1 times 325 is 325. Add those partial products. We get 0, 10, regroup. 2 plus 6 is 8, plus 1 is 9, and 3. So we end up with this product of 3900. Now, if you remember what we said here, this is too large. 3,900 is too big. We need to make it 100 times smaller. So the way to do that is, we could go ahead and take our decimal point here, right here, and we'll move it over 1. There's 10 times smaller. There's 100 times smaller. So we end up with an answer of 39. Now let's go back here and look for reasonableness. So if I recall, 32, my original problem here, 32.5 is about 30. So let's go ahead, it's about 30. And 1.2 is about 1. So 30 times 1 is 30. So I know my answer, my product, has to be around 30, which, if you look, 39 is close to 30. So my answer is reasonable. That is the correct placement of the decimal. Yes! Ka-chow! What a transition, right? Blank space. Here's another way I want to show you how to do this problem. So I like to look at these decimal points here, these decimal places here, and I like to think of them as they're a little out there. Well, they're a little eccentric, they're a little different because, you know, they're decimals, they're not whole numbers like 35 and 1. So what I like to think of them as is this. I like to make them wear hats. Hats, you might say? Yes, hats. So we're going to give this 2 a hat. Oh, that's a fancy dandy hat there. And I think we need another fancy dandy hat for this 2 here. So for every number with a decimal place, we're going to give it a fancy hat. Now I want you to remember, while we're working with the problem, they can't wear the hats, because I mean, come on, while you're working you don't wear a hat. So we're going to take the hats off for right now. So let's go through this problem again. Same thing. You're going to see the answer in 3, 2, 1. Snap, boom. Oh, it's like amazing. I know what, your teacher's magical. Hey, what can I say? I'm like a unicorn or something. Anyway, so we've got our answer down here, 4,224. But remember, we took the hats off. You got to put the hats back on. So let's go ahead and put the hat on this guy. Put the hat on this guy. That means now that our hats are back, folks, our decimal has to be right here. Am I reasonable? Let's find out. 35 is about 30. 1.2 is about 1. 30 times 1 is 30. That is close to 42. I am awesome. And I'm reasonable. I know. Let's try another one. Ka-chow! So let's look at this. We're going to look at this problem 2 different ways. The first way is getting rid of these decimals, because I don't like these decimals. So what we're going to do is we're going to make that into 232, and we're going to make this into 54. So if you think about it, we made that 100 times bigger, and we made this 10 times bigger. So there's 3 decimal places. That means we're actually doing 232 times 54, and then times 1,000th. 10, 100, 1,000. 10 times 10 times 10 is 1,000. So we have to make it 1,000 times smaller eventually. So work the problem out with me here. So 4 times 2 is 8. 4 times 3 is 12. 4 times 2 is 8 plus 1 is 9. I'm done with this. Done with this. Sad. So 5 times 2 is 10. 5 times 3 is 15. Plus 1 is 16. 5 times 2 is 10. Plus 1 is 11. So I end up with partial products added up. 8, 2, 15, 2, and 1. So I end up with 12,528 here. But remember, this is too large. I was multiplying 232 times 54. My actual numbers were 23 and 2/10 times 54 hundredths. So I have to make this answer 1,000 times smaller. So we move it 3 decimal places to the left. So we go 1, that's 10, 2, that's 100, 3, that's 1,000. So my decimal should go there. Is it reasonable? Let's look back here. So if we think about it, 23.2 is about 20. 0.54 is it's about half. So half of 20 is 10. 10 is close to 12, so I am reasonable. Whew. Let's look at it the other way and bust out some sweet hats. Is your teacher a wizard? No, it's just technology, guys. Come on, give it the program here. The thing that I want to point out, especially here in this example, is that you'll notice the decimals are not lined up. When you are multiplying decimals, you do not have to line up the decimal point, which is awesome. If you add or subtract, definitely line it up. So, look, I've got this decimal place, this one, and this one. I think they need some sweet hats, ladies and gentlemen. So, there's a hat for you. That's a giant hat. Shrink that a little bit here. Here's a hat for you, and hat for you, and a hat for you. But we can't do math while these hats are on, so let's set our sweet hats off to the side for right now, and we'll put them back on later. So we're going to magically do this math here in 3, 2, 1, bang, crash, and we're back. So I end up with this answer. Now let's put my hats back. So a hat for you so you look fancy, a hat for you so you look fancy, and a hat for you so you look fancy. We've got our hats there. That means our decimal place has to go there. If we go back up, because check for reasonableness. That's about 20. That's about half. Half of 20 is 10. So I am reasonably awesome, of course, here. Last example. Boo. There's a scary thought I bet you didn't think you were going to see, huh? So here's what we're going to do. We're going to look at this problem that we have on the screen. I don't know why I'm going like this because you guys can't see my hand. How about I go like this instead? There we go. We're going to look at this problem on the screen here. I want you to pause it, and then I'm going to give you a 3 count, and then I'm going to give you the answer. So pause it right now. You haven't paused it. Pause it. Now, go for it. And 3, 2, 1. Pow! So I already put hats on there for you. Hopefully you already figured this problem out. So I'm going to go ahead and pull the hats off for right now. And then in a couple seconds, let's go ahead and work this problem out. Let's check how you did. So 5 times 7 is 35. Carry the 3. 5 times 2 is 10 plus 3 is 13. 5 times 0 is 0 plus 1 is 1. 5 times 3 is 15. Carry the 1. 5 times 2 is 10 plus 1 is 11, folks. Notice, try to keep those columns nice and straight as we've got here. So don't need this, don't need that, don't need that. Boom, kick, cry, baby. Yes. Feel the tears come down. All right. Sorry, I may have some issues. 2 times 7 is 14. Carry that 1. 2 times 2 is 4 plus 1 is 5. 2 times 0, 0. 2 times 3 is 6. And 2 times 2 is 4. Fantastic. If we add this together then, it's going to happen. Boom, just like that. So now we're going to go put our hats onto our answer. So there's one fancy hat. What did I do? Oh no, my hat's mixed in. Here, here, here. And I guess since I messed it up somehow, I'll draw my last fancy hat right here like that. Which means my decimal has to go here. Now if we go back and check for reasonableness, 23 is about 20, and 25 hundredths, it's about a tenth. You could think of it that way, or you could do half of a half. But for right now, we'll just say this. So 1/10 of 20, move it this way, gives me an answer of 2, and 2 is by 5, so that is a reasonable place to put my decimal in this case. Now, you've got a couple different strategies that you could go about to actually do this. So, go ahead, check this. Hopefully you can get rid of your curse. And there's something that I must tell you, something very important. Listen very carefully. The darkness consumes all. The darkness consumes all.